Hello, my name is Junhyuk Kong, and today I will be talking about a physics topic, energy and work. To start off, it's really important to understand what energy is all about. Simply put, energy is the ability to do work, which is the ability to exert a force causing displacement of an object. It is the force that causes things to move. The reason why energy is so important when solving physics problems is that it is a more powerful way to solve problems in a simpler form. There are two types of energy, kinetic and potential energy. You can understand it easier if you think of kinetic energy as moving and potential energy as quote-unquote off ground. I will get into more details about this later. There are also different forms of energy, which are light energy, heat energy, mechanical energy, gravitational energy, and vice versa. But these are not very important in this lesson right now. Now, moving on from energy, what is quote-unquote work? Work is basically what you do to create the energy. The work you do becomes the energy the object now has. Work is calculated in joules, and you can find how much work you have done by multiplying the force you have applied to move an object by the distance you apply force over. So for example, if I say I push a box with 100 newtons of force over 3 meters, then you will have done 300 joules of work because 100 times 3 is 300. Moving on, law of conservation of energy. Knowing this law concept is very vital in fully understanding the idea of energy and solving physics problems involving energy. The law of conservation of energy states that no energies are lost and that energy can neither be created nor destroyed. It is only converted from one form of energy to another. In other words, a system will always have the same amount of energy unless it's added from the outside. An object will always have the same amount of energy, but the type of energy it has will change. Objects usually start from potential energy and move towards kinetic energy. Objects start with all potential energy, then the potential energy decreases as height goes down. When the object begins to fall, the potential energy turns into kinetic energy. To help understand the idea of the law of conservation energy, you can think of the graph or the image in the bottom right. The area or the whole box is the total amount of energy. The total amount of energy will not change and will always be constant. However, the type of energy will differ as the object will begin to have more kinetic energy than potential energy as an object drops from a distance. The object will have kinetic energy when it is moving and will have potential energy when it moves quote-unquote off ground. For instance, when I grab a ball and move it off the ground, it begins to gain potential energy. The higher I go, the more potential energy it has. Now, when I drop the ball from mid-air, the ball begins to move downwards, which is when the potential energy turns into kinetic energy. Another real-life example is the well-known bowling ball experiment. For those of you who do not know what it is, it's basically a person holding a bowling ball in front of their face and dropping it without exerting any force on it. Then, the ball will swing back and forth, but will not hit the person's face because of the law of conservation of energy. The bowling ball does not create any energy and has the same amount of energy throughout the process, and therefore the bowling ball will not hit the person's face. Conceptually speaking, the bowling ball is able to go back and forth forever continuously, but that is not possible in real life due to air resistance and other minor factors. Now, the formulas for the energy. As previously mentioned, there are two types of energy, kinetic and potential. Ke, or kinetic energy, is equal to 1/2 times mass times velocity squared. In this equation, the only value that will change throughout the problem is only the velocity because mass will always be constant. Next, PEG, or potential energy of gravity, is equal to mass times 9.8 times height. The h stands for the height above the ground, and the 9.8 stands for the acceleration due to gravity. This means that every second an object is in freefall, gravity will cause the velocity of the object to increase by 9.8 meters. Continuing on, this equation represents the law of conservation of energy. The left side of the equation stands for the object at the beginning, and the right side of the equation stands for the object at the end of the problem. Notice how the left and right are equivalent to each other. This shows that no energies are created nor lost, and the total energy stays constant throughout the problem. If you plug in the equations from the previous slide into this whole big equation, you will get mass times 9.8 times height plus 1/2 times mass times velocity squared is equal to mass times 9.8 times height prime plus 1/2 times mass times velocity prime squared. For this problem, we know that mass is 5 kilograms and height is 10 meters. To solve, we simply plug in these numbers into the equation, which gets us 5 times 9.8 times 10 plus 1/2 times 5 times 0 squared, because the object is at rest in the beginning, meaning the velocity will be 0, is equal to 5 times 9.8 times 0, also because the height will be 0 when the ball falls down to the ground, plus 1/2 times 5 times velocity squared. When you simplify the equation, then isolate the velocity, you will end up with the final velocity of 14 meters per second. Next example problem is a ramp problem. However, the steps are the same. You will plug in the numbers into the equation. 5 times 9.8 times 10 plus 0 equals vice versa. In the end, you will get a value of 14 meters per second. But wait, notice how the answer for the first example problem and the second example problem is the exact same, even though one question was ball free falling from midair, while other one is falling from a ramp. You might think this is coincidence, but it is not. If you take a good look at the equation, notice how the values that change are only mass, height, and velocity. And if you remember from a few slides back, I told you that the mass does not change because the mass is always constant. This means that if height and the mass of the problem is equivalent to each other, the final velocity will always be the same no matter what. Regardless of how the ball falls, the velocity will always be the same if the height and the mass of the object is equal to one another. Here are two other ways a ball could fall down. One looks like a steep slope and the other one is like a roller coaster. But if you do the math and calculate the final velocity, you will also end up with the same exact answer as the previous two questions. Lastly, I will quickly summarize the main concepts in today's lessons and end it off. First, energy is the ability to do work or the ability to exert a force causing displacement of an object. There are two types of energy, kinetic and potential energy. Work is what you do to create the energy. Law of conservation of energy states that no energies are lost and that energies can neither be created nor destroyed. It can only be converted from one form of energy to another. An object will always have the same amount of energy, but the type of energy it has will change. Here is an important formula you should keep in mind. PE plus KE equals PE prime plus KE prime. In mathematical terms, it will be mass times 9.8 times height plus 1/2 times mass times velocity squared equals mass times 9.8 times height prime plus 1/2 times mass times velocity prime squared. When the mass and the height is the exact same value, the final velocity of the object will be identical to each other regardless of their falling position or how they fall down. This sums up my lesson on energy and work, and thank you for watching.